We have our derivative of natural log of x is 1 over x right here. And we have our derivative of arctangent is 1 divided by 1 plus x squared. And we have our arcsine derivative equals 1 divided by square root of 1 minus x squared. So let's see how those work when solving some problems. Here's a problem, f of x equals natural log of 5x squared plus 3. The derivative of the function is 1 divided by the inside function times the derivative of the inside function with the chain rule, so that's equal to 10x over here, and then we just multiply that over and we finally get this right here. Another one is f of x equals arctangent 3x. So our arctangent rule says that it should be 1 divided by 1 plus the function squared times the derivative of the function using the chain rule. And so that's simply 1 divided by 1 plus 9x squared. Derivative of 3x is 3. So we get this result here. Now here's an example of this one, cosine of arcsine of x, inverse sine of x. So differentiating that straight away would be negative sine of the inside function times the derivative of the inside function. But sine of the angle whose sine is x is x, and then times the derivative of the arc sine, which would be here. So the final result is negative x divided by square root of 1 minus x squared. Another way to do that is over here. We notice that if we're dealing with arcsine of x, we call that an angle whose sine is x, so that sine theta is equal to x. So we have, if we put theta right here and draw a right triangle, then this will be x over 1 will be the sine of theta. That forces this side to be square root of 1 minus x squared, so that the cosine of theta is adjacent over hypotenuse, which is this right here. So the function, the original function, cosine of that angle is just square root of 1 minus x squared right here. So then if we differentiate that, we get this step, which is equal to this, which exactly matches up with what we had previously. So actually you could do it two ways. Then we have this problem right here. This one. Natural log of secant x plus tangent x. So we have derivative of log of a function is 1 over the function times the derivative of the inside function. Then when we go to do that, we have to go over to the side over here, the secant here. The derivative of secant works through here with the chain rule and ends up with secant x tangent x. So coming back over to the left, there's your secant x tangent x, and of course the derivative of tangent x is secant squared x. factoring out secant x out of that expression, then these two would cancel and you just get secant x. And that's going to be very important later, because we'll see that we have secant x, the antiderivative, will be natural log of absolute value of secant x plus tangent x plus a constant. Then one last one here. The derivative of a to the x is a to the x log a. So if you're doing this problem here, 2 to the e to the x plus 1, that's up in the exponent. So we'll have 2 to the function log 2 times the derivative of the inside function with the chain rule, and the derivative of e to the x plus 1 is just e to the x. So there's your solution. And you can do any of these problems by going to Wolfram Alpha and putting in deriv for a derivative, or you could write the whole word derivative, put the function in there, and click the little equal sign over here, and you'll get the answer, plus you'll get some useful information about graphs and different things.